Imagine you are floating in space. It is cold, it is dark, silence surrounds you. Slowly, something begins to emerge from the blackness. A sliver of light appears, it grows, a vast, curved shape takes form. Swirls of orange, white, brown paint its surface. The shape is immense, a world so large it could hold all other planets. This is Jupiter. It hangs in the void, a silent king in a dark kingdom. We have watched it for centuries through our telescopes. We have sent probes to fly past its beautiful, dangerous clouds. We thought we knew it, but do we? What secrets lie beneath those swirling storms? The old story of Jupiter was simple. It was comforting. For many decades, our textbooks told us a clear tale. Jupiter was a gas giant, a beautiful but simple planet. The idea was that it formed far from the sun, where it was cold enough to gather huge amounts of hydrogen and helium gas. This gas, we thought, just got thicker and thicker as you went down, deeper and deeper. At the very center, the pressure was so great that there had to be a small, dense core, a solid ball of rock and ice, maybe 10 times the mass of Earth. It was a neat and tidy picture, a planet with a simple, predictable structure. This model made sense. It fit with our understanding of how planets form. So for a long time, we pictured it like a piece of fruit, a small, hard pit at the center, surrounded by a massive, fleshy layer of gas. This image was in our encyclopedias. It was in our science documentaries. It was the established truth. But science is not about holding on to old truths. It is about challenging them. Our early robotic explorers gave us our first close-up looks. Size, mass, clouds. But they were flying by quickly, scratching only the surface. Measurements of Jupiter's gravity field were a little bit messy, like a beautiful piece of music with strange notes out of tune. The neat, clean layers were a fantasy. The reality was far more chaotic. To understand Jupiter, you must first understand its power. The most defining feature of Jupiter is its immense gravity, the bully of the solar system. Its gravitational pull is more than twice as strong as Earth's. If you could stand on a platform floating in its upper clouds, you would feel incredibly heavy. An object that weighs 100 pounds on Earth would weigh about 250 pounds on Jupiter. This gravity captured vast hydrogen and helium and holds the planet together. It is the engine that drives everything we see. As you go deeper, the pressure builds at an incredible rate, like diving into the deepest ocean. But it just keeps going. Pressure changes the very nature of matter. Gases are squeezed until they become liquids. Things we think of as light and airy become as dense as rock. The rules are different here. Rapid spin and rising heat create gigantic weather patterns, the bands and stripes that circle the globe. Rivers of gas flow east and west at hundreds of miles per hour. Not gentle breezes, but planet-sized jet streams. Think of a pot boiling on a spinning turntable, stretched into long, swirling lines. This is not just weather. The planet itself is alive with motion and energy. Among all the storms on Jupiter, one stands out. It is a storm so large it could swallow the Earth whole. We call it the Great Red Spot, observed for over 300 years. A hurricane of unimaginable scale with no land to stop it. It has raged for centuries, perhaps millennia. Winds have been measured at over 400 miles per hour, more than twice the strongest Earth hurricanes. An anticyclone, a high-pressure vortex rotating counterclockwise in the southern hemisphere. It rises high above the surrounding clouds. Its deep reddish color may be sunlight-cooked chemicals dredged from below, but we are not entirely sure. The planet's great red eye, and it is not alone. Jupiter is covered in storms. Countless white ovals and brown ovals, some as large as continents. They collide, they merge, they dance in a complex ballet. At the poles, giant cyclones arrange in perfect patterns. 8 around 1 in the north, 5 around 1 in the south. Formations that remain remarkably stable. Why so violent and long-lasting? Internal heat and rapid spin. With no solid surface to sap their strength, these storms are free to rage for centuries. Jupiter is not just a planet with weather. Jupiter is weather. For a long time, we wondered what lay beneath Jupiter's thick clouds. We knew the pressure increased dramatically. But what happens to hydrogen under such extremes? Go deep enough, and the most common element in the universe is squeezed so hard it changes form. It stops being a gas. It becomes a liquid metal, a hidden ocean of metallic hydrogen, a vast conductive sea. Imagine descending, ammonia clouds, clouds of water ice, then a thick hydrogen shroud. The pressure builds, the temperature soars. Thousands of miles down, pressures reach millions of times Earth's surface. Hydrogen atoms are forced so close together that electrons are squeezed out, free to move, like in a copper wire. The hydrogen has become a metal, hot, dense, utterly alien, a fluid more like liquid mercury, under conditions we barely replicate on Earth. Predicted in the 1930s, only now are we gathering confirming evidence. This strange substance is the key to Jupiter's biggest secrets. Because it conducts electricity, and, as it spins, it can power a planetary dynamo. On Earth, liquid iron does this. On Jupiter, metallic hydrogen does, on a grander scale. And it creates the most powerful magnetic field of any planet in our solar system. A hidden engine, humming in the dark. Flowing from the heart of Jupiter is an invisible force of immense power, its magnetic field. A magnetic bubble stretching for millions of miles into space. If we could see it, it would dwarf the planet. Larger than the full moon in our sky. Nearly 20,000 times stronger than Earth's. A direct consequence of that deep, spinning ocean of metallic hydrogen. It traps charged particles from the solar wind and from volcanically active Io. These particles are accelerated, creating intense radiation belts, among the most dangerous places in the solar system. Any spacecraft that gets too close must be heavily shielded to survive constant high-energy bombardment. The field's dance with the solar wind creates auroras that are thousands of times more powerful than Earth's, glowing in ultraviolet and X-ray, and they never stop. But the field is lumpy and strange, strong in some places, weaker in others. It tells us the dynamo is closer to the surface than we expected. The transition from normal to metallic hydrogen is a complex, churning zone. The magnetic field becomes a map, revealing the chaos hidden beneath the clouds, an invisible shield, and a luminous signature of the forces within, signals from a giant's heart. In 2016, something new arrived at Jupiter, a NASA spacecraft named Juno. Not a flyby, an orbiter, flying closer than any spacecraft before it. It swoops over the poles, ducks the worst radiation, and skims just above the clouds. Its mission: peer beneath the clouds, measure gravity with exquisite precision, map the magnetic field, and reveal the interior. What Juno found has been, in a word, shocking. The old, simple model is gone. Juno's gravity measurements show a planet not neatly layered, but mixed up in strange ways. The heavy elements we thought were locked in a compact core are mixed far into the envelope. The biggest shock: a fuzzy, dilute core. No hard boundary, a vast, slushy zone, perhaps reaching nearly half Jupiter's radius. As if an original core dissolved and was stirred into the deep atmosphere over billions of years. One theory: an ancient collision with a planet-sized body shattered the primordial core and mixed its fragments into the hydrogen sea. It paints a brutal past for a beautiful giant. Juno has given us answers, and a new set of mysteries. The textbooks are being rewritten in real time. Let's put the pieces together. It starts with the spin. A 10-hour day acts like a giant blender, organizing weather into stripes and girdling jet streams. Without this, Jupiter would be a lumpy, boiling ball of gas. The spin brings order to chaos. Then, add heat. Like a failed star, Jupiter lacks fusion, but retains immense internal heat from formation. That heat flows outward, churning the atmosphere from below, unlike Earth, where the sun drives the weather. This internal engine fuels giant storms, swirling vortices, and incredible wind speeds, Jupiter's atmospheric fire. Add the strange physics below. Pressure turns hydrogen into a sea of liquid metal. But Juno shows the transition is not a clean line. It is messy, reflected in the lumpy magnetic field we observe. Those lumps and bumps are a direct map of chaotic processes tens of thousands of miles below. Finally, the fuzzy core, a huge dilute mixture of rock, ice, and hydrogen. Heavy materials may still settle slowly, or be continuously stirred by powerful convection. Jupiter is not finished. It is a dynamic system, an engine of chaos from heart to cloud tops. Beautiful, organized chaos. The most profound secret Jupiter is sharing is the nature of its core. For generations, we imagined a small, solid ball, rock and ice, a planetary seed buried deep. Juno's precise gravity forced us to erase that drawing and start again. The data tells a different story. Not small, not solid, not distinct. A fuzzy, diluted heart. Imagine a vast, slushy region where original rock and ice are mixed with metallic hydrogen. It may stretch across a huge volume, perhaps 30 to 50% of the planet's radius. The heaviest elements aren't neatly tucked at the center. They are smeared across a vast zone. How does a core become fuzzy? The leading hypothesis, a dramatic, ancient impact. Soon after Jupiter formed, a massive protoplanet, perhaps 10 Earth masses, may have slammed in at incredible speed. Catastrophe. The compact core shattered, scattering rocky and icy fragments through the deep interior. The fuzzy core we infer today may be that ancient scar. It changes how heat flows, how storms behave, and how the dynamo works. Not an isolated fact, a key piece of a shocking, coherent story. A giant with a broken, beautiful heart. We have journeyed from a simple picture of a gas giant to a complex world of strange metal, geometric storms, and a fuzzy, shattered heart. Each discovery opened a dozen new questions. Juno's revolution is not over. With every close pass, our gravity and magnetic maps sharpen. Piece by piece, we are building a new portrait of the King of Planets. Future missions are on the drawing board, an atmospheric probe to measure composition, temperature, and pressure directly. A one-way trip, a sacrifice to science, crushed by immense pressure, but sending priceless data to the very end. Is the fuzzy core the scar of a giant impact, or evidence of an even stranger process? How deep do the storms and jets go? Do they reach the metallic layer? What sculpts the polar cyclone polygons? Is Jupiter becoming more mixed, or slowly settling into layers? We have watched for a cosmic blink. Its long story remains hidden. For so long, we saw a simple, majestic king on a distant throne. Now we know the truth, a world of chaos, violence, and a broken heart. This is science. Start simple. Gather evidence, and see the universe as it truly is. And as we look ahead, one question remains. If we were so wrong about Jupiter, what else are we wrong about?